Hello guys, welcome to today's class. I'm a maths tutor and today I'll be looking at polynomials. Alright, so what are polynomials? Polynomials are expressions formed from the sum of integral non-negative powers of a variable x taken together with some numerical constants. So we generally write polynomials in this form: a subscript n x to the power of n plus a subscript n minus 1 x to the power of n minus 1 plus we can write up to a subscript 2 x to the power of 2 plus a subscript 1. Yeah, it will be x to the power of 1, but it doesn't change anything, so I'm going to leave that, and then plus a subscript 0. Now, why did I write everything here? From when we have a subscript n, a subscript n minus 1, and up to a subscript 0 are all numerical constants. Alright, they are all constants, so they could be numbers in the form of 2, 5, 7, 6, 3. Those are constants, not variables. That's the first take. The second is a subscript n minus 1, and up to a subscript 2, a subscript 1 are coefficients. Alright, they are coefficients. What are they the coefficients of? They are coefficients of the variables x to the power of n, x to the power of n minus 1, and then up to x to the power of 2 and x. So these are coefficients of these particular variables. Alright, now, so if you look at this, you discover that we didn't write this last one here, a subscript 0. Because a subscript 0 is called the constant. A subscript 0 is the constant. It is not a coefficient. It is not attached to a variable. So a subscript 0 is a constant, or is the constant in that particular polynomial expression. Alright? So another thing to note is that the highest power of the variable is n. If you look at the polynomial from the beginning, discover that we started with n, right? And then the next one is n minus 1. It means that we are reducing the power. We are reducing the power, and then we go to 2, and then we go to 1, and then we get to the last one, which is x to the power of 0. So the highest power of this variable is n. N is the highest power, and we call it the degree of the polynomial. So if we had a polynomial with, let's say, a subscript 3 x to the power of 3 plus a subscript 2 x to the power of 2 plus a subscript 1 x to the power of 1, yeah? So the highest power is 3, right? If 3 is the highest power, it is also called the degree of the polynomial. So this is a polynomial. This is a polynomial of degree 3. So the highest power informs us of what the degree would be. So examples of polynomials are we generally designate polynomials with p of x. All right, so examples of polynomials are, let's say p of x is equal to 3x squared minus 2x plus 4. We could also have p of x equal to 3x to the power of 4 minus 2x squared plus x minus 1. Please take note, we could also use q of x. We could use anything, but I'm using p of x. And examples of things that are not polynomials are, let's say we have f1 of x, and then we have the square root. of x squared plus 2x minus 3. This is not a polynomial. Or we have 3x squared minus 4x squared plus 2x minus 1 divided by 2x plus 3. This is also not a polynomial. Now, I'm going to look at addition and subtraction of polynomials. So let's say we have p of x and it's equal to a subscript n, x to the power of n, plus a subscript n minus 1, x to the power of n minus 1. And then we keep going till, let's say, a subscript 2, x to the power of 2, and then plus a subscript 1, x plus a subscript 0. And then we also have a different polynomial, q of x, which is now b subscript n, x to the power of n, plus b subscript n minus 1, x to the power of n minus 1. And then we keep going to b subscript 2, x to the power of 2, plus b subscript 1, x to the power of 1 here, which we don't write, plus b subscript 0. Now, the addition, I'll do both addition and subtraction together. The addition of this polynomial, p of x plus q of x, is written in this form. We take out the coefficients first, a subscript n plus b subscript n, and then we write the variable attached to it, because we don't add the variables together, we only add the numbers attached to it, which is the coefficient. Alright, plus the same thing for the other one, a subscript n minus 1 plus b subscript n minus 1, x to the power of n minus 1. And then plus up to plus a subscript 2, yeah, plus b subscript 2, x to the power of 2, plus a subscript 1 plus b subscript 1, yeah, x plus a subscript 0 plus b subscript 0. Now, if it was negative, the only difference would be that we'll change, okay, let me not clean that. Let's write plus there. We just change the sign to minus. So if it was negative, we have minus instead of plus, right? We have minus instead of plus. That's the only difference for negative and positive. So that's the addition or subtraction of polynomials. Let's look at some examples. So our first example is this. We are giving, let's take this as an example. Oh, sorry. We are giving that first polynomial p1 of x. Let me divide this beforehand. p1 of x is 7x cubed minus 4x squared plus 3x plus 4, right? And then we have a second polynomial, p2 of x is 5x squared plus 6x plus 1. And then we have the last polynomial, I'm going to call that p3 of x, and it's 4x cubed plus 2x minus 3. Now, the question says find a p1 of x plus p2 of x, b p3 of x minus p2 of x, and then c 3p2 of x plus, I'm going to clean a little bit here, plus 2p3 of x. Alright, so how do we find the answer to these particular problems? So first of all, it's very easy. p1 of x plus p2 of x out. I'm going to write out the first polynomial, which is this p1 of x, 7, put it in a bracket, 7x cubed minus 4x squared plus 3x plus 4, that's p1 of x. And then we are adding p2 of x, which is this, plus 5x squared plus 6x plus 1. The next thing I'm going to do is to look for the algebraic terms with that are alike, all right? So 7x cubed doesn't have its own like term in any of the expressions. So I'm going to write that out, 7x cubed. However, we have 4x squared, x squared is also here. So that's how we choose the like terms. X squared is in the first expression and in the second expression. So I'm going to write plus, but in these brackets, I will take this minus alongside. Minus 4x squared plus 5x squared, which is gotten from the second expression. And then we have 3x and 6x, they are like. So plus 3x plus 6x. And lastly, we have 4 and 1, which are the constants, plus 4, I'm seeing the clean here, plus 4 plus 1. All right. So this is going to give me 7x cubed minus 4x squared plus 5x squared plus 1x squared. And I don't need to write 1, the coefficient which is 1, I don't need to write it, I'll just write x squared. Okay, 3x plus 6x is 9 plus 9x, and then 4 plus 1 is 5 plus 5. That is A. Now let's go to B. B says the third polynomial minus the second polynomial. The third polynomial, P3 x minus P2 of x, is the same thing as 4x cubed, please put that in a bracket, plus 2x minus 3 minus the second polynomial, 5x squared plus 6x plus 1. Alright. As we did in the first example, we're going to do it here. Take the like terms. X cubed doesn't have a like term here, so we just write 4x cubed. X squared also doesn't have its own like term here, so we still write minus. Please take note of the sign in between, minus 5x squared. However, 2x has its like term, so we say plus 2x plus 6x. Good. And lastly, plus the constants, minus 3. Take note, this is also minus plus 1, which is minus 1. So minus 1. And that would be 4x cubed minus 5x squared plus 2 plus 6 is 8. That's 8x. And oh, I just discovered that we made a mistake in this sign here. We made a mistake in the sign, so it's not going to be 8. The mistake we made was this. We said these are like terms, correct? This is 2x, this is minus 6x. Minus plus 6x is minus 6x. So we do make mistakes sometimes. So 2 minus 6 is not going to be positive, it will be negative. Minus 4x. And then minus 3 minus 1 is minus 4. Good. The last example for addition and is the last one, C, 3p2x plus 2p3x. That would be, you are multiplying, first of all, you are multiplying p2, which is 5x squared plus 6x plus 1. You're multiplying it by 3. And then you're also multiplying p3, which is 4x cubed plus 2x minus 3 by 2. This will give me 15. 3 times 5 is 15. 15x squared. 3 times 6 is 18 plus 18x plus 3 times 1 is 3. Plus 2 times 4 is 8x cubed. Right? 2 times 2 is 4x. 2 times 3 is minus 6. And then 2 times minus 3. Alright, so this will also look for the like terms. However, take the term with the highest degree first, which is 8x cubed. So we have 8x cubed, which doesn't have its like term, and 15x squared, which also doesn't have its like term, plus 15x squared. And then we also have plus 18x, and then plus 4x. And lastly, plus 3 minus 6. So this will be 8x cubed plus 15x squared plus 22x minus 3. So this is how we add or subtract polynomials. Now I'm going to be looking at the multiplication of polynomials. After multiplication, we look at division, and then it will be all for today. How do we multiply two polynomials? Take note the product. Let me write that down. The product. Before I write this, let me write at the top. Multiplication of polynomials. Multiplication of polynomials. So take note the product of two polynomials of degree m and n. This is degree, please. Degree m and n is another polynomial. Remember, the degree of a polynomial is the highest power in that polynomial. All right, so it's another polynomial of degree n plus n. You will see the reason why we gave that definition. So we have this example. I'm going to be using two methods to get this answer. So we are given that P1, P subscript 1 of x is 2x squared plus 5x plus 6, and P subscript 2 of x is 3x squared minus 2x plus 1. And we are told to find the multiplication P1 multiplying P2. Or P1, let me put this first, P1 of x multiplying P2 of x. So this would be, I'll be dividing it into two methods. As I said, method one will be multiplying it the way we multiply algebraic expressions. All right, so P1x times P2x would be 2x squared plus 5x plus 6 multiplying 3x squared minus 2x plus 1. So I will take them individually. We have 2x squared. That will be multiplying 3x squared minus 2x plus 1. And then we have plus 5x multiplying 3x squared minus 2x plus 1. And then lastly, plus 6. It means we are multiplying, taking this individually, and we are multiplying everything here. Plus 6 multiplying 3x squared minus 2x plus 1. Good. So we'll be having 2 times 3, which is 6. Remember the rule. The product of two polynomials of degree m and n is another polynomial of degree n plus n. So the highest degree we'll be having is the addition of these two and these two. Right? 2 plus 2 is supposed to give me 4. So the highest power should be 4. 2 times 3 is 6. X squared times s squared is x to the power of 4. 2x squared times minus 2x is minus 4x cubed plus 2x times 2x squared times 1 is 2x squared. 5x times 3x is 15x cubed. 5x times minus 2x is minus 10x squared. 5x times 1 is plus 5x. And then we have lastly 6 times 3 is 18x squared, yeah. 6 times 2 is minus 12x, and then 6 times 1 is 6. You have to be careful so you don't make any mistake. So now we have 6x to the power of 4, and then we have minus 4x cubed here. We also have a like term there, so we'll write plus minus 4x cubed plus 15x cubed. We could also just say minus 4 plus 50 and then write x cubed at the end of the brackets. It doesn't matter. So plus, now we have 2x squared and minus 10x squared. And then we also have these like terms. Oh, we are not true. We have another like term for x squared, which is 18. So plus 18x squared. Hope you can see that that's plus 18x squared. Okay, so now the second to last is 5x and this. We have plus 5x minus 12x, and then we have lastly plus 6. So if you take all these, we'll be having 6x to the power of 4 minus 4x cubed plus 15x cubed is 11x cubed. 2x squared minus 10x squared is minus 8x squared plus 18, that's plus 10x squared. 5x minus 12x is minus 7x, then plus 6. I said I'm going to use two methods, so let's do the second method. Alright, for the second method, when we multiply in this way, remember we're multiplying p1 of x, which is 2x squared plus 5x plus 6, and p2 of x, which is 3x squared minus 2x plus 1. Here's how I multiply. I can write 2x squared plus 5x plus 6, and then I write 3x squared minus 2x plus 1. So I'm multiplying this way. First of all, I'm going to have 1 times 6, which is plus 6. 1 times plus 5x, which is plus 5x. And then 1 times 2x squared, which is 2x squared. Now we use minus 2x to multiply 6 will be minus 12x. Minus 2x will multiply 5x, and that would be minus 10x squared. Minus 2x will multiply 2x squared to give minus 4x cubed. Lastly, we have 3x squared multiplying 6 to get plus, yeah, that's a positive, plus 18x squared. 3x squared will multiply 5x to give plus 15x cubed. And then 3x squared multiply 2x squared to give plus also, which I don't need to write. Okay, plus 6x to the power of 4. So now we just add up everything here. So take note, you multiply everything here, you add up everything here. We have 6, 5 minus 12 is minus 7, minus 7x plus 6, please take note that's plus. 2x squared minus 10x is minus 8x squared, plus 18, that's plus 10x squared, minus 4x cubed plus 15x cubed is plus 11x cubed, and then lastly we have 6x to the power of 4. Compare what we have here with what we have here. We discover that we have the same answer. So those are the two methods I talked about. Lastly, I'm going to look at division of polynomials. For division of polynomials, a polynomial of degree n can be divided by another polynomial of degree m. However, the degree at the top must either be greater than or equal to the degree at the bottom. Now, if we are dividing a polynomial p1 by another polynomial p2, we'll be calling p1 the dividend, and then we'll be calling p2 the divisor. Right? The result we get from this division will be called the quotient, and anything that is left after this division is called the remainder. Okay, so we have also the remainder, anything that is left after this division. So let's look at an example quickly and get the solution. So let's say we have to divide 4x cubed plus 6x squared minus 2x plus 7 by 2x minus 3. And we have to find the coefficient, find the, sorry, not the coefficient, the quotient, sorry. To find the quotient and the remainder. Find the quotient and find the remainder. This is how we do division. It's the long division, 2x minus 3, and then we have 4x cubed plus 6x squared minus 2x plus 7. So this is how we divide. First of all, we divide this 4x cubed by 2x, all right, by 2x, and then this will be 2, write it at this part, 2x to the power of 2, because by removing one of the x here we have 2, and then by dividing this we have 2x squared. So now you multiply 2x squared with this divisor. 2x squared times 2x is 4x cubed. 2x squared times minus 3 is minus 6x squared. Yeah. So now we subtract. Since these two are the same, they cancel out as 0. 6 minus minus is plus. That's 6 plus 6 is 12x squared. And then we'll bring down minus 2x. The next thing we do is repeat the same process. 12x squared divided by 2x, this 2x here. Alright, so this will be 6, and this is removing one of x, so that's plus 6x plus 6x. 6x times 2x is 12x squared. 6x times just minus 3, that's minus 18x. So if you subtract 12, well cancel 12, and then we have minus 12 minus minus 18, which is minus 12 plus 18. That's going to give you 16x. Lastly, bring down 7 plus 7. 16x divided by 2x is going to be 8, just 8. And then 8 times 2 is 16x. 8 times 2x. Lastly, 8 times minus 3 is minus 24. So if you subtract, this is 0. 16 minus 16 is 0. But we have 7 minus minus 24, which is 31. That is the remainder. So now our quotient, which we are told to find, is 2x squared plus 6x plus 8, which is the result. Remember, I said that the quotient is the result. This is the result. This is the quotient. While our remainder is simple. I said whatever is left is the remainder. Our remainder is 31. Where did we get 31? At this point. Alright, so this is how we look for divisions of polynomial. As I said at the beginning, I'm a maths tutor. If you have any problem, math related problem, please send me a DM and let's try to fix it up. Till meet again, bye.